This sample exercise is to learn how to write chemical equation for neutralization reactions. For the reaction between an aqueous solution of acetic acid and barium hydroxide, write the balanced molecular equation, the complete ionic equation, and the net ionic equation. Now here, let's understand that we have a neutralization reaction where a neutralization reaction is an acid that reacts with a base. So we need to identify which of this is the acid and which one if this is the base. Obviously here by the name we have the acid, we have the, in this case we easily identify the acid, so the other one is the base. But also if you don't have the names, this is really important, you can see that you have an OH here. This OH is part of an ionic compound. So that's why this hydroxide is the one that is going to be a base. This one, you have here an OH, but this one is not part of an ionic compound. So that's why this OH is not a base. Okay, that's if you don't have the names, you can identify it easily by looking at the molecular formula of each compound. Once again, this OH is part of an ionic compound. OH is not part of an ionic compound. The one that is part of an ionic compound, that compound will be the base. So here we have the base, and here we have the acid. But as we mentioned before, we have the name, so it's easily to identify that from this in this example. So we are given the chemical formulas for an acid and a base and asked to write a balanced molecular equation, a complete ionic equation, and a net ionic equation for the neutralization reaction. So the plan is that we know the neutralization reaction forms two products, water and a salt. We examine the cation of the base and the anion of the acid to determine the composition of the salt. Now, if this is the base and this is the acid, remember that the acid will release one hydrogen. So it's going to release this hydrogen here. So you're going to have this anion because you're going to remove the hydrogen that is positive. So here you will be left with this anion that is acetate. Okay, when you remove this hydrogen, you will have this anion that is acetate. So this acetate will react, that is the cation, will react with the anion that will react with the cation of this one, it's the barium. So you will produce the barium acetate as the product, as the salt of the reaction. Okay, once again, this is an acid. The acid will release one hydrogen, that is this one. The hydrogen is positive, so that means that you will be left here with a negative charge for this anion that's going to be the acetate. And this acetate, the anion, will react with the cation of the base, that is the barium, to produce the salt, because this hydrogen will react from one of the OH to produce the water. And actually, I can see here that we have here an error. This two must be outside of the parenthesis. So it's parenthesis OH parenthesis, and the two goes in the outside. So you have two of the OH. So by saying that this hydrogen will react with one OH that will produce water, and this barium will react with the anion that will be produced by this acid releasing the hydrogen. So the salt contains the cation of the base, that is the barium, and the anion of the acid, that is the acetate, to produce the barium acetate. And according to the table of solubility, this compound is soluble in water. The unbalanced molecular equation for the neutralization reaction is the acetic acid times the barium oxide. Here is written the right way. We have the two outside the parenthesis, producing water. Remember that this water is produced by one OH from here and this hydrogen. And the barium acetate, the acetate from here, okay, and the barium from this one, the anion from here, and the cation from here. So here we have the molecular equation for this neutralization reaction. But as we can see here, we have in this compound, we have two acetate. So that means that here we just have one. Remember that this acetate comes from the ionization of this acid. So this is the source for the acetates, and we have here two. So that means that we need two here. But if we add 2 here, that means that we're going to affect this hydrogen. That is the one that we are releasing, so it can bind to the oxygen and to the hydroxide to create water. So if we have 2 hydrogens and we have 2 hydroxide, that means that we're going to produce 2 molecules of water. So we need to balance this equation, okay? And as I mentioned, we have 2 molecules. We need to provide 2 molecules of acetic acid. So in that way, we can have 2 of the acetate. And as well, we add 2 hydrogens here because we're going to add that 2. So that means that we're going to produce 2 molecules of water. So now we have a balanced equation. Now we have 2 acetates here that are balanced, this 2, plus we have 2 hydrogens that will react with this 2 hydroxide to produce the 2 molecules of water, and we have 1 barium and 1 barium. Now that we have our balance equation, molecular equation balance, now we need to write the complete ionic equation. To do this, we need to identify the strong electrolytes. Remember that the strong electrolytes most of the time is going to be ionic compounds, or for example, a strong acid. And this one is a weak acid. So here, this barium hydroxide and the barium acetate are the only ones that will be dissociated. Okay, so we're gonna basically break them into ions. And here we have the barium hydroxide, and here we have the barium and the acetate. And now that we have the complete ionic equation, we have the hydroxide, we have 2 from here, we have 2 here, and also from this barium acetate, we have 2 acetates, and we have the barium by itself. So we have from here, we can see that the only species that you find also in the product is the barium. So that's the spectator ion. So we need to cancel that barium, and then we will have the net ionic equation for this neutralization reaction. As we mentioned before, the product is water plus the salt that's going to be barium acetate eventually in solution. Okay, so that's the product of the neutralization. So once again, here we have the balanced molecular equation. Then we need to establish the complete ionic equation by doing the dissociation of the ionic compounds. And in this case, is barium hydroxide. We have 2 hydroxide here, and the barium acetate. So barium and also the acetate, we have 2. And then we cancel the spectator ions, that in this case is going to be just barium. And also the other molecules, they have basically uh, a common factor, that is 2. So we can divide all of them by 2, and that's why here we don't have the 2, because we divide each of them by 2, and then we cancel those coefficients because they are basically the same. And this is our net ionic equation. So we can determine whether the molecular equation is balanced by counting the numbers of atoms of each kind of both sides of the arrow. That will mean that we're going to have 10 hydrogen, 6 oxygen, 4 carbon, and 1 barium. However, it is often easier to check equations by counting groups. As we mentioned for the acetate, instead of counting 2 carbons, 3 hydrogens, and 2 oxygen, as we have here, we can count this as 1 acetate. So we have 2 acetates in the product. So as well as 1 barium and 4 additional hydrogen atoms and 2 additional oxygens on each side of the equation. So we can also, instead of looking by individuals atoms, we can look for groups of ions or atoms. So the net equation, ionic equations, check out because the numbers of each kind of element and the net charge are the same on both sides of the equation. As we can see here, we have basically, this is the molecular equation, and this is the net ionic equation. Here at the end, we have 1 acetic acid here that will provide 1 acetate that we have here, and this hydrogen will react with this hydroxide to create 1 molecule of water. So our net ionic equation also is balanced, and the net charge in the reactant is -1 because the hydroxide, we have a -1. This one doesn't have any charge. And here in the products, water is neutral, so acetate is -1, so we have a similar charge in both sides of the equation.